So we've covered some of the main concepts of stoichiometry, and all of those concepts apply to chemical reactions. Now, the majority of chemical reactions in the universe occur in solutions, when substances are dissolved in water. So in order to really understand these reactions, we need to review the concepts of solubility and electrolytes. So, refresher from CP Chem, solubility, word definition to know. Solubility is the ability of a substance to dissolve. It's a measure of how well something dissolves. Okay? And there are usually two vocab words associated with solubility: solvent and solute. And when we're describing substances, the solute is what you have less of, and the solvent is what you have more of. So for example, let's say we take some salt, some sodium chloride, NaCl, as a solid, and we drop it into this beaker that is filled with water. We stir it up. Now that this solid is dissolved in water, we would say that it's no longer NaCl solid, it's NaCl AQ. And this AQ means aqueous, which means dissolved in water. So we need to remember that. We need to recognize AQ anytime we see it. It means a substance that's dissolved in water. In this case, since we have very little salt relative to the amount of water, NaCl is going to be our solute, and H2O would be considered the solvent. Now, what actually happens when we drop NaCl into water? Well, it starts to dissolve. And we use this term all the time, but our knowledge, what we need to know, is the concept of what's actually happening to the atoms when this substance is getting dissolved. So, if we zoom in here, we zoom in on these salt molecules in here, what's going on with them when they're getting dissolved? So, we can see here, these green spheres have little negative charges, and these small purple spheres have positive charges. So clearly these represent different ions. So NaCl, what is it going to split up into? How is it going to dissolve? Well, NaCl is going to split into its respective ions, which would be Na, and since sodium is a group 1 metal, it would be Na plus 1. And chlorine, as a halogen, is going to be Cl minus. So these are the two ions. Again, if you don't remember this word, it means an atom with a charge that NaCl, sodium chloride, is going to dissolve into. So these are now floating around in solution. Well, what's going to happen then? If you remember from CP Chem, we acted this out a bunch when we went outside, and some people were NaCl, some people were water molecules, and the water molecules, the solvent, is moving around randomly. So what we have here is all these water molecules. Each one of these is H2O. These things are moving around randomly throughout the beaker. And when they collide with that salt, that NaCl, enough times with enough molecules, they will surround one of those ions, pull it apart, break it apart, as you can see here, break it apart, and then we would say that that NaCl is becoming dissolved. Later in the year, we're going to talk about exactly which direction and orientation these water molecules will face, because it depends on the structure of the molecule. But what we need to know right now, for this purpose, is, okay, what does solubility mean? It's a measure of how well something dissolves. How can we identify the solvent and the solute in a solution? NaCl, when it dissolves, what's actually happening? The ions are getting broken apart by the solvent molecules, and this molecule is becoming ionized. Okay? It's becoming ionized. Another vocab term to know, this is when a substance turns into its ions. So NaCl turns into Na plus and Cl minus. What if we wanted to make this NaCl dissolve faster? What are some things that we could do? Well, since this whole process here of dissolving is dependent entirely on the motion of the molecules, anything that increases the molecular motion is going to increase the solubility. So, for example, we could stir it up with a spoon. That's going to make the molecules move around more, they're going to collide more often, the substance is going to dissolve quicker. We could also increase the temperature. We could heat up this water. If we heated it up, that means these molecules now have more energy, so they're moving around faster, which means they're going to collide more frequently with the salt and dissolve it. We could also increase the surface area of the salt. By crushing up the salt into a finer powder, we're making these pieces smaller so that they're easier and can be broken down easier and broken apart much more quickly by the water molecules. There's one more term we need to know. Any substance that can be ionized is called an electrolyte. Again, any substance that can be ionized is called an electrolyte. So for example, NaCl can be ionized. It can break into Na plus and Cl minus. So it is considered an electrolyte. Basically, essentially, any ionic compound. So MgCl2, that can split into Mg2 plus and Cl minus. This would be considered an electrolyte. And electrolytes have unique properties, which we'll look at in class, but you need to know that definition as well. If we look at a chemical reaction that shows solubility, what is actually going on? Well, in this case, we have two solutions. We have AgNO3 and CaCl2. So this is silver nitrate dissolved in water, and this is calcium chloride dissolved in water. And we're going to mix these together into one beaker. And what's going to happen? We can tell first they're dissolved in water, remember, because it says aqueous. But when this happens, we form AgCl solid and CaNO3 aqueous. What does this solid mean? This means that a solid was formed from two solutions. They were liquids originally. This is called a precipitate. A precipitate is a substance, a solid that forms from soluble salts. So when you take two aqueous solutions, you mix them together and you form a solid, you have formed something called a precipitate. Now, you're not always going to form a precipitate in a chemical reaction. Some compounds, when mixed together, will form precipitates, and some substances, when mixed together, won't at all. And the way that we can predict which compounds will form precipitates and which will not has to do with something called our solubility rules. Solubility rules. So I know in AP Chem I said there are very few things that you have to memorize. This is one of the things that you have to memorize. Our solubility rules. Our solubility rules are really simple. They're really simple. Okay. Compounds with a group 1 metal or ammonium, NH4 plus. This is something you have to have memorized. It's called ammonium, the ammonium ion, are soluble. So, what does that mean? Well, first of all, this must be memorized. Anything with a group 1 metal or NH4 is soluble. So this means we take X plus Y reactants and we form a new compound that is NaNO3. We form sodium nitrate. And we want to know, is this going to be a solid precipitate or is it going to be aqueous? Well, our solubility rules tell us that any compound with a group 1 metal or ammonium ions will be soluble. So this compound, does it have a group 1 metal or an ammonium ion? Yeah, it's got a group 1 metal, sodium. So this is soluble, which means if it's soluble, it's going to be aqueous. It's not going to form a precipitate. So this would be aqueous. What about another one? Let's say we had potassium sulfate, K2SO4. Is it going to be solid or aqueous? Well, again, does it have a group 1 metal or an ammonium ion? Potassium, K2, That's a group 1 metal, so this is not going to form a precipitate. This would be aqueous. It would dissolve. What about another one? What about, we'll do it up here for room. What about ammonium carbonate, NH4,2CO3? Is this going to be solid or aqueous? Well, it has an ammonium ion, NH4, so therefore it's always going to be soluble. It's always going to be aqueous. What about another one? Let's say we did MgOH2, solid or aqueous. Well, in this case, it does not have a group 1 metal, and it does not have an ammonium ion. So we can't say for certain that it's soluble. We can't say for certain that it's aqueous. We also can't say for certain that it's going to be a solid. So in fact, if you got a compound like this that does not have a group 1 metal or an ammonium ion, we don't know. We don't have to have it memorized. The old AP Chem curriculum you did, but not anymore. We would need more information in the problem. The problem would have to say MgOH2 is formed as a precipitate. Then we know it's a solid. Or the problem would say MgOH2 aqueous is formed. Then we know it's a solution and that it is soluble. So these solubility rules you have to have memorized. You have to be able to recognize if I give you a compound like this, or like this, or like this, you have to be able to tell me is it soluble or not. We need to recognize and know the definition of the term precipitate. Again, we'll look at a demo of this in class tomorrow. And you also need to have, I know this is a little bit messy, definitions for solubility, for an electrolyte, for solvent, for solute, for ionized, memorized, and you need to know what is actually happening when a substance dissolves.